Hi there. For this question, we're going to take into consideration all of our analytic geometry principles. A question like this incorporates several things that you should know from the CST mathematics course, including how to calculate the midpoint of a line, which is a location, a Cartesian point x and y, the division point, which is also a point on a line, but it's not in the middle, and the distance of a line, which is its length. For this question, it asks us to consider the following diagram showing line segments AB and CD. Point E is the midpoint of line segment AB, and point F is located 1/4 of the length of CD. We'd like to find out the distance between points E and F. Now this might seem somewhat overwhelming, but actually we're using three key analytic geometry principles to solve it. The first sentence is the first one that I'm going to attend to. It says, consider the following diagram showing line segments AB and CD. So you can see that these are two different lines, AB on the left and CD on the right. Point E is the midpoint of AB. So let's start by finding point E. Now point E is the midpoint, and I've written three formulas up on the right-hand side. When we're looking for a midpoint, we're actually looking for some kind of xy value in the Cartesian plane that marks the location of the middle of the line. To do that, the formula is quite simple. We average the values of x and we average the values of y on the endpoints of the line segment. So I'm going to use A as x1 and y1, and B for x2, y2. Now it doesn't matter, because if we're talking about the middle of a line, it doesn't matter which end is which in terms of x1, y1 and x2, y2. I tend to go left to right in my diagrams for this. Also alphabetically, A comes before B, so often I'll label it that way. So I'm going to employ the formula where we average the values of x. So -2 plus 4 divided by 2. And for the y value, we're going to do the exact same thing. So -2 plus 4 is +2. And 2 plus 5 is 7. And we can convert these to a decimal. Fantastic. Now I'm thinking about the next sentence. Point F is located at 1/4 the length of C to D. Now this is where order really matters. If I'm traveling from C to D and I'm talking about 1/4 of the way along the line, I'm saying that, well, this is one segment out of 4 segments along the line that make my journey. However, if I started at D, for example, and went back to C, it would be 3/4 of the way along the journey. So order really matters when we're looking at this particular equation. So to use point of division, we have to be mindful that it's the length of CD, not DC. So for division point, it's a similar formula where we're looking for an xy coordinate at point F. To do this, I'm going to employ the division point formula. I have to label point C x1, y1, because that's our starting point, and D is x2, y2, because that's our endpoint of segment CD. So let's find point F. So x1, so that's 2, plus our fraction a over b, x2 minus x1, and that's all we have to do for our x-coordinate. For our y, it's the same procedure. Now I notice we have 5 minus negative 3, and that's okay. I'm going to leave it like that for just a moment. I'm going to rewrite this by doing BEDMAS and doing the brackets first. 6 minus 2 is 4. And 5 minus a negative becomes a positive, so it becomes 5 plus 3, which is 8. Now some students proceed to go left to right here and they end up with the wrong answer because they add 2 plus a quarter and then times it by 4, which is not correct using BEDMAS. So always attend to the back end first of each of these so that you have the multiplication carried out first. So I'm going to leave the 2 out there and say, well, what's 4 times a quarter? So 4 times 1 divided by 4 is 4 over 4, which is 1. Negative 3 plus, now again, 8 times 1 is 8, divided by 4 is 2. And then I get my new point here, 3, negative 1. So that's point F. So now we have point E and we have point F, and we want to know the distance of the line segment that would be created between them. So to do that, let's use our distance formula to find line segment EF. Now in this case, we're not looking for a point on the Cartesian plane, we're looking at the actual length of a line segment. Our distance formula, so distance from E to F, is going to use the rule above. Now in this particular case, it doesn't matter, again, which one is x1 and which one is y1, x1, y1, and which ones are x2, y2. And the reason is, if I was going from my house to your house and it was 2 kilometers, whether you started at my house and went to yours, it'd be 2 kilometers, or started at yours and went to mine, it would still be 2 kilometers. So distance, it doesn't matter what the order is. So I'm going to label point E x1, y1, and point F x2, y2, and I'm going to plug it into my formula here for distance. So 3 minus 1 all squared, and then I'll do the same for the y's. Negative 1 minus 3.5 all squared under the root sign. Now some errors happen here. Again, you have to kind of do the BEDMAS first. 3 minus 1 is 2. And negative 1 minus 3.5 is negative 4.5 squared. Now, if students don't put in their negative 4.5 in parentheses in their calculator, they often get a negative answer for squaring. But remember, whenever you square something, it has to be positive. So 2 squared is 4, and negative 4.5 squared is 20.25. Now we can add these two values together, and we get 24.25. But remember, that's still under the root sign. The square root of this answer is not a perfect integer, but it's a decimal of approximately 4.92 units. And that's the length of the line segment from E to F.